Good day everyone. Today we will talk about Shapes demo. Taological AI is totally different from what we see in the internet, the mainstream AI. Instead of giving answers based on probabilities, it gives answers based on reason and logic. From our logical specifications, it will give us an executable software on the fly. The answer came from the reasons we gave it, from our logical specifications. We just have to say the meaning, the reason, the logic, the relationship between shapes, and it will understand what we mean and will arrive to the goal we want to reach. In this case, we want to have a software that is able to tell us if two shapes are the same or different. A simple example for us to get a glimpse of the power of Tau. So let's begin to prove this by writing our logical specifications on Tau language REPL. The specifications you're about to see are provided by our community member PTTKK. Great job, PTTKK. To see more of his work, I suggest you visit Tau Forum. Many of the codes are really interesting, but I tell you, they are technical. So, expect that I will give more discussions to that in the next videos. Please support my channel by subscribing, liking, and sharing this video. It will help me a lot in growing my channel as well as so others may also understand and learn about this great technology. I have a separate video in the playlist where I teach how to install Tau language REPL both in Windows and Linux. Mac OS is still under development. And also, I would also like to see an Android version so we can play Tau language REPL anywhere with our phones. Here we write down the main idea, the concept. So the concept is a square has 4 sides and a triangle has 3 sides. Then we write the relationship between the two shapes. If the two shapes have the same sides, then they are the same. If they have different sides, then they are different. Then Tau will give an executable software that is correct by construction. Means it is 100% guaranteed to be aligned with our logical specifications. So for example, you're a programmer and you have a client, let's say a school, and this software is intended to teach a child in kindergarten. You want to make sure that your software will work correctly. You don't want something to happen like when a student asks, is a square same as a triangle? You don't want your software to have a mistake and say, yes, they are the same. You want your software to always do what it's supposed to do based on your specifications. You want to make sure that the software will always give you the result you want to happen. You want a serious example? You don't want a software to make mistakes and interchange the units of metrics and English measurement system. That's a costly mistake. But for simplicity, let's use this shapes demo for example for now. So, let's begin to open our Tau language REPL. Mine is Ubuntu Linux OS here. And also, let's open the codes that is given by PK. This is our Tau forum. You can visit this at tau.forum and you will learn more about the codes. So right now we will focus on shapes. Okay, so we will copy this one. Sometimes I make mistake in copying. So anyway, mistakes, we learn from mistakes. So in this example, we're trying to compare whether a triangle is the same as a square. Common sense tells us that this is different, but AI right now still has no common sense. Joke. So you gave it expensive billions of training data set and still gets mistakes. Ouch. But with Tau, since we have taught Tau the relationship between shapes and sides, it is able to understand the meaning behind this reasoning and gets the correct answer 100% all the time. For common sense reasoning, a triangle has three sides and a square has four. So this is not the same. In tau, the result is false. So this means that we are, example, we are proposing. Example, we are the student now. Example, um, this is the, we are the programmer, right? Example, right now we're a programmer. And then we already write our specifications. And from this, we already have the software. Now we give it to the student. And the student asks, um, is triangle the same as a square? Okay, so so when we ask that, so I don't expect the student to know how to code like this, but just for an example, okay. So this is triangle. Is it the same as a square? Okay. What is your guess? It's false, right? So why? Because it has three sides and this has four, so it's false. Now we want to compare. Again, we are now the student, the kindergarten student. We want to compare the shape of a triangle. Is it the same as the shape of a triangle? Common sense tells us it is the same. The reasoning behind that is because they have same number of sides, 3, 3. So let's see here. So instead of square, this is triangle. See? I already have the software. This is the code specification. And now, tada, I already have. So you might ask, where is the while? Where is the if then else? Or where's the, it's all here. That's amazing, right? So yeah, Tao can reason. Tao knew the results because we have given Tao our logical specifications in advance. Here's the logical specifications, right? We don't need billions of training dataset to teach the AI. We just write our specifications and that's it. And the results are guaranteed 100% always correct based on our logical specifications. Yeah, for sure, if your specifications is wrong, don't blame Tao, right? So it will depend really on our specifications. So the correct our specifications, the correct results, right? So not like the mainstream AI where we already given it tons of data sets to learn from, yet it's still not able to give us the correct answer all the time. We may scratch our head and ask, so, how many examples do we need in order for us to make sure this AI will learn? I don't know. We also don't know how it arrived with an answer. But with Tao, since we are the one who gave the fundamental idea, the concept, this is the concept, right? The fundamental idea. We are sure we know how it will operate, and we are sure what will be the results. Tao solves the problem of AI safety and transparency. If mainstream AI is a mystery box, where we don't know what is the next result, Tao logical AI is a glass box. Here is it. Okay? So here, so I hope you get the point. I hope it's clear. So here it's, are they the same? The square and the triangle? Square has 4, triangle has 3. For sure it's false. So false. Again, where's the code? Where's the code? Tau generates it. 100% correct based on our logical specifications. And lastly, is a square same as a square? What do you think? It's true. Why? Because the reason is that square has 4 sides and another square is 4 sides. So this is just a simple example. If you have time, you can develop this and add more shapes. Yeah. So like a pentagon or octagon, but the concept remains the same. The fundamental concept. Tao is able to reason based on our logical specifications. I highly recommend installing Tao language REPL and play with the codes. Though it was just released recently as it is an alpha version, Tao devs are still fixing some bugs. If you have found one, you can write it in a GitHub issue section. Okay? The more people see the bugs, the better, as it will help speed up the development progress. No need for billions of training dataset to learn from, since Tao doesn't learn from trial and error. It does not guess. Tao learns from reason and logic. You don't have to say it twice. There is a term we call when a person doesn't understand even if you said it many times. Oh no. No need to worry if it's aligned with what you want to happen. We just write down our logical specifications and Tao automatically creates a software that meets our specifications. In machine learning AI, they give you code snippets and you have to run the code and check and debug if they work according to what you want to happen. But you are not guaranteed it will work. In Tao, as we have seen here, the software is correct by construction. We are sure that the output it gives will always be 100% aligned with the reasoning we gave it. Imagine how fast, cheap, transparent, and safe the AI we can create. I understand that right now we struggle, me personally, struggle in writing this logical specification, right? This is how did you get it? How did you arrive with this? We just don't normally think like that. I have not been able to do this video without PTTKK's great who is great in logic, and he shared this code with us. But beyond that learning gap, we are able to successfully create a software on the fly, guaranteed correct, and 100% aligned with our specifications. So, how are we able to write our own Tao software? This is by controlled natural language. So this makes it easier for us to create a Tao software. It is like an ordinary language, how we speak, but there are limitations to it. Our choice of words should be accurate, clear, and straight to the point. It should not be open for personal interpretation, since our goal is for an AI to be aligned. Therefore, it should start from us that our goals are clear. Shout out to our community member Logix, who has been working nonstop, providing codes, and also now he is currently working on the controlled natural language for Tao. Thanks for your great work in supporting our Tao project. I hope to see the final product soon. I believe it will be a great resource for the community. I believe that the controlled natural language, with that feature, Tao would be much easier to use to create executable software on the fly, just like what we have produced now, where we just have to say what we want our software to do or not do, and it will be created automatically based on what we say. We call it software as sentences. While waiting for the grand demo of OHAD, which is to demonstrate the true power of the Tao language, I highly recommend you to learn Tao language REPL. There are great documentations and resources in GitHub, and You can also join our Tau Dev Telegram group and Tau forum to learn more about Tau language and other topics in the Tau project. In the next video, we will compare which sides have greater sides, or greater than or less than. Is a triangle greater than or less than square? The first formula is a comparator where the first int is a variable that represents the number of sides of the first shape to be compared. The second int is a variable that represents the number of the sides of the second shape to be compared. Both int have x, means both have the same number of sides. If so, the comparator formula will give a t or true result. The second formula is also a comparator, but now the second int has y inside. This means that if the two variables are not the same, the result of the comparator will give an f or false result. In the third formula, we declare the number of sides of a square, which is 4. In the fourth formula, we declare the number of sides of a triangle, which is 3. In the fifth formula, this formula is the formula we will interact to test if the shapes have the same sides or not. Now that we have written our logical specifications in traditional coding, we need to compile and run the codes, right? In Tau, we don't need to. Tau automatically creates a software that is already executable. Our goal is to create a software that is able to determine if the two shapes are either different or the same. Now let's run the software. To do this, we will write n for normalize, then the fifth formula, same, then we write what we want to compare. In the first example, we compare square and triangle. Tau gives a result of f. Tau has successfully created a software from our logical specifications. It has created the software that is able to determine if the two shapes are the same or not. We can clearly reason why Tau gave the result of f because that's what we wrote in our specifications up there, reflecting the second formula, comp int x 1, int y 1, f, which means if both sides are not same, then give the result of f. Again, on the third example, Tau has successfully created a software that meets our logical specifications. Because here, we see square and square will be true. Why? Because of our logical specifications we gave to Tau. On our first formula, comparator int x, comma int x equal to t, this means that when both int has the same x, then this means they are equal. So give the result t or true. Thank you for listening. Have a wonderful day. See you. Bye.